In the last video, we started to look at logarithms. A logarithm is simply the power a base is raised by to give us a certain value. So if we have log to the base 2 of 8, that's 3, as 2 to the power of 3 is equal to 8. In this video, we're going to look at evaluating logs and converting from log to exponential form and from exponential to log form. So let's go ahead and look at some examples. We're asked to express each of the following in the form log to the base a of b is equal to c. So let's first write the exponential equivalent. We looked at this in the last video. If we have log to the base a of b is equal to c, then the exponential equivalent is a to the power of c is equal to b. The logarithm is simply the power the base a is raised by to get the value of b. So if we look at the first one now, we could write this as log to the base 10 of 1000 is equal to 3. We could have written this now as log. In the calculator, we have 3 different buttons. We're going to have a look at those now. The first one is here, and I could have put in base 10. So if I put in now base 10 of 1000, that is going to give us 3. If I just use log, that is base 10. So if I put in now 1000, that will give us 3 as well. We also have the natural log, which is base e, and in later units we're going to use that. For now, we only really look at these two. So if we see log, that just means now base 10, or LG is just base 10. So with this one, we could write this 2 different ways. Let's look at the next one. 3 to the power of 4 is 81, so we can say log to the base 3 of 81 is equal to 4. If you like, you can just jam that power there. 3 to the 4 is 81, so log to the base 3 of 81 is equal to 4. If you want to let this form guide you, you can now just look at the values and sub them in. This one right here, we can say log to the base 2 of 256 is equal to 8. 8 is the power 2 is raised by to get 256. If we look at the next one, we've got 7 to the 0 is equal to 1. Log to the base 7 of 1 will be equal to 0. This gives rise to an important result. One of the laws we can use is log to the base a of 1 will be equal to 0. We know that a to the 0 will always be equal to 1. 10 to the power of 0 is 1, 100 to the power of 0 is 1, and then we can just write this. So this is a rule if you want to write that down. If we look at the next one, we can write log to the base 3 of 1/27 is equal to minus 3. So that now is the equivalent statement. If we look at this one, we can say now log to the base 32 of 1/2 is going to be equal to minus 1/5. We know if we raise 32 to the minus 1/2, we will end minus 1/5, we will end up with 1/2. If we just look at that, 32 to the minus 1/5, we could write this as 1 over 32 to the positive 1/5 power. If we take the 5th root of 32, we end up with 1 over 2. So that's just writing now the log equivalent. Okay, let's do one more. We've got now 19 to the 1st is equal to 19. We can write log to the base 19 of 19 is equal to 1. And in general, this gives rise now to the rule log to the base a of a is equal to 1. That makes sense. If we raise now a to the power of 1, we just get a. 2 to the first power is 2, 3 to the first power is 3, and so on and so forth. Okay, let's move on. We're asked to express each of the following using index notation. So let's go back to our definition. Log to the base a of b is equal to c, and then the exponential equivalent is a to the c is equal to b. So in this particular question, we're going to work in the opposite direction. So with this one now, the power 5 is raised by to get 125 is 3. So we can write the exponential equivalent 5 to the 3rd is equal to 125. If we look at the next one, we know that 2 to the power of 4 is 16, so we can simply write 2 to the power of 4 is 16. The log is the power the base is raised by to get the given quantity. The next one, we could have now 10 to the power of 5 is going to be equal to 100,000. Again, with that one, you might have just seen 5 is equal to log of 100,000. This one right here, we can write now as 23 to the power of 0 is equal to 1. Now we know that 9 to the half power is equal to 3, so we can write now the exponential equivalent is 9 to the half power is 3. That's the square root. So all I'm doing is switching the form. Let's just look at this one. This now is LG. That's log, or base 10. So if we looked at what we've got here, we've got now log to the base 10 of, and this is going to be 1/100th. I know that 10 to the minus 2 will give me 1 over 10 squared, so we can simply write now log to the base 10 of 1 over 100 is going to give us minus 2. Therefore we can say 10 to the minus 2 is going to give us now 0.01. That is the exponential equivalent. Okay, let's look at this one now. That's nice and straightforward. 2 to the power minus 3 is going to be 1 over 2 cubed, which is going to give us now 1/8. The last one right here, we're looking now at 6 to the first power is equal to 6. So 6 to the first is 6. And that makes sense, as we know that log to the base a of a is equal to 1. Okay, without using a calculator, find the exact value of the following. So we've got now log to the base 7 of 49. So what we're looking at then is the power 7 is raised by to get now 49. If you like, you could just write this as follows. Let's just write now that this is equal to x. It's equal to some value. If I wrote now the exponential equivalent, it's 7 to the x is equal to 49. What power is 7 raised by to get 49? Well, the answer is going to be equal to 2. So if you want to look at it like that, you certainly can do. What power is 4 raised by to get 64? Well, the answer is 3. This is the log. That now is the power. The base 4 is raised by to get 64. This one right here, 2 to the power of 7 gives us 1/8. The next one right here, what power is 3 raised by to get 27? The answer is positive 3. 5 to the power of 4 is 625, so log to the base 5 of 625 is 4. What power is 8 raised by to get 8? Well, the answer is going to be equal to 1. Again, if you wanted to write that, you could write this now as log to the base 8 of 8 is equal to some value x. Therefore, we can say 8 to the power of x is equal to 8 to the power of 1. X is equal to 1. I think that's long-winded, but it's an option for you. If we look at this one right now, we could go ahead and write the exponential equivalent, and the exponential equivalent is 7 to the x is equal to 1, so we could see that x is equal to 0. So whilst I'm going around this a slightly longer way, it's entirely up to you on how you want to look at it. Working between the log and exponential form is something that you will have to get used to. So what power is 15 raised by to get 1/15? Well, the answer is minus 1. So we're going to have minus 1 just here. If we look at this one right here, what power is 3 raised by to get now 1/9? So what you could do is write 3 to the power of x is equal to 1 over 9, or 1 over 3 squared. So we can see that x would be equal to minus 2. We know 3 to the power of minus 2 is going to give us 1 over 3 squared. If we look at the next one, what we have is log to the base 10 of now 0.001, which is 1/1000th. Okay, so log to the base 10, not 100, log to the base 10 of 1 over 1000, well, this is going to be now minus 3. If I have now 10 to the power of minus 3, that's going to be 1 over 10 cubed, which is going to be 1 over 1000. If we look at this one now, we can say that 16 to the power of x is going to be equal to 2. We know that x will be equal to 1/4. 16 to the 1/4 power is equal to 2. If you like, you could write this now as 2 to the power of 4 raised to the power of x will be equal to now 2 to the power of 1. I think this is a long-winded way around, but if you want to, you can do that. Therefore, we're going to have, using the rules of indices, 4x is equal to 1 and x is going to be equal to 1/4. I don't suggest that you would need to do that, but it's an option for you. All you're thinking about now is the logarithm is the power 16 is raised by to get to. Okay, let's look at this one. What power is 4 raised by to get to 8? Well, we need to take the square root of it and cube it. So we can say now that log to the base 4 of 8 will be equal to 3 over 2. If you like, you can say 4 to what power is equal to 8, and then you can go ahead, and if you want, you can write those now as powers of 2. If you really wanted, you could write this now as 2 squared to the power of x is going to be equal now to 2 cubed. So using the rules of indices, we can see now that 2x will be equal to 3, as we've got now a to the m raised to the n, so we multiply. If the base is the same, we can equate the powers, so x is equal to 3 over 2. It's often easier to think of it now as a numeric value. Let's look at this one. Now I know that if I have 3 to the power of 5, I get 243. So what I need to do is take the square root and raise it now to the power of 5. So log to the base 9 of 243 will be equal to 5 over 2. Again, you could write this as 9 to the power of x will be equal to 243. So you could say now 3 squared to the power of x is equal to 3 to the power of 5. So we can say that 2x is equal to 5, and then we can say that x is equal to 5 over 2. So that's entirely up to you. This time we've got log to the base 100 of 1000. So we could say now that 100 to the power of x is equal now to 1/1000th, and let's write this here, 1/1000th. Now we could write this as now 10 to the power of minus 3. So this is another way of looking at it. I'm kind of leaving this open to you. It's entirely up to you. So if we think about this now, this is going to give us 10 squared to the power of x is going to be equal to 10 to the power of minus 3. So using the rules of indices, 2x is going to be equal to minus 3, and x is going to be equal to minus 3 over 2. This one right here, what power is 25 raised by to get 125? Well, we would take the square root and cube it. So we'd end up now with 3 over 2. So if you want to do it in your head, you can do. This one right here, we would need to take the cube root, then we would square it, and then we would make it negative. So we take the cube root, we square, and we make negative. So we're going to have minus 2 over 3. Again, if you wanted, you could write that as powers of 3. So what we'd have is 27 to the power of x is equal to 1 over 9. So writing these as powers of 3, we could have 3 to the power of 3 raised to the power of x will be equal to 3 to the power of minus 2. Therefore, we can see that 3x would be equal to minus 2, and we can say that x would be equal to minus 2/3. So entirely up to you. If you want to do it in your head and work numerically, you might find that slightly easier. Okay, without using a calculator, find the exact value of x in each case. So this one, we got loads of different examples. Now what I'm going to do with these is take each by turn. Often it's easier to write now the exponential equivalent and work through them. So if we think about this one now, the exponential equivalent is 5 to the power of x is equal to 25. So what power do I need to raise 5 by to get 25? Well, the answer is x is going to be equal to 2. Alternatively, you can just think now, I'm going to jam this little number here. What do I need to raise 5 by to get 25? The answer is x is equal to 2. By writing the exponential equivalent mode, you might find that easier. If we write the exponential equivalent, 2 to the power of 6 is equal to x. Well, 2 to the power of 6 is going to give us 64, so we'd have now 64 is equal to x. Or, what number do I need to raise 2 by to get, let's work this out. If 2 is raised to the 6th power, what number do I get? That's essentially what we're saying with that one. I don't think that's a very good explanation, but hopefully it's made sense. Okay, with this one now, we could say what number is cubed to give 64. So writing the exponential equivalent, x to the power of 3 is equal to 64. So taking the cube root of 64, that's going to give me now 4. So again, if we look at that, 4 to the power of 3 is 64, or if I put 4 in here and I want to now get 64, I need to raise it to the 3rd power. Right, this one right here, let's rewrite this. What we have is log to the base 10 of x is equal to minus 3. So what we could write now is the exponential equivalent, and that is 10 to the power of minus 3 is equal to x. So 10 to the power of minus 3, let's just do it here, is going to be 1 over 10 cubed, which is 1 over 1000. So just writing this, rewriting it might make your life easier. Okay, what number do we raise to the power of 2 over 3 to get 16? Well, what we could write now is x to the power of 2 over 3 is equal to 16. Therefore, x is going to be equal to 16 to the power of 3 over 2. All I'm doing is essentially solving an equation. I've just raised both sides, and we looked at this in an earlier unit on the rules of indices. So I need to take the square root and cube it. That's going to give me 64. So we end up now with 64. Let's just check that that makes sense. So if I put 64 in and I take the cube root, that's going to be 4, I square 4 and I get 16. All I've done here is just simply, and I'll rewrite it here, x to the power of 2 over 3 raised to the power of 3 over 2 will be equal to 16 to the power of 3 over 2. So using the rules of indices, a to the power of m raised to the power of n is a to the power of m multiplied by n. The fractions will give us 1, so we can rewrite. Okay, let's look at this one right here. Now, what we're looking for now is the number that 4, in fact, we've jumped ahead, haven't we? Let's go for the next one. So what we've got then is 5 to the power of x is equal to 1, or if we like, what do we raise now to 5 2 to get 1? Well, that's x is going to be equal to 0. What number do I need to raise by the power of 1 to get 9? Well, the answer is going to be 9. If you like, you could say x to the first is equal to 9, so x is going to be equal to 9. Okay, what I'm going to do with this one right here is come back to it. The reason being is I want to use a different rule on it. We can, of course, deal with it here, but I want to use an alternative rule for this one as we look later, and that's called the power rule. So I'm going to leave that one till next time. Okay, let's look at this one right here. First thing I'm going to do is divide both sides by 2. So I'm going to have log now to the base x of 7 is equal to 1/2. So writing now the exponential equivalent, x to the power of 1/2 is equal to 7. I'm going to square both sides. If I square x to the half, I'm going to get x. If I square 7, I'm going to get 49. So we can say that x will be equal to 49. Does that work? Well, 49, if we want to raise 49 to a certain power and get 7, that's going to be the square root of a 1/2 power. Okay, let's look at this one now. What we're going to have is 4 to the power of 1.5 is equal to x. So I'm going to write that as the power of 3 over 2, and that will be equal to x. So if we consider now 4 to the power of 3 over 2, we take the square root and cube it, that is going to give me 8. So does that make sense? Well, if we put 8 in there, we take the square root and cube, and that will now give us our value right here. Right, let's look at this one. So what we have then, and I'm going to write this as 1 over 10 will be equal now to x, and then we're going to have the power of minus 1/3. So what we could do at this stage is write 10 is equal to x to the power of positive 1/3. When I'm doing this, I'm kind of thinking out loud, and alternatively, you can do it a slightly different way. What we need to do is cube both sides. If we cube both sides, we're going to end up with x is equal to 1000. Okay, let's look at this one. I'm going to subtract 1 from both sides and divide by 3. So we have log base 8 of x will be equal to minus 1/3. So let's write now the exponential equivalent. 8 to the power of minus 1/3 will give us now this value of x. So if we think about this now, I need to raise both sides to the power of minus 3. So 8 will be equal now to x to the power, in fact we'll just do this numerically rather than waste that. Let's just go ahead and do this. So what we can write then is fine, rather than me mess about, we can write this as 1 over 8 to the power of positive 1/3. That would be a lot easier. Take the cube root, that's going to give me 1/2. So x is going to be equal to 1/2. So we've gone ahead and solved that particular equation. So there we go, that's what we would do. Sometimes, I mean, we will be expected to evaluate certain logs when we don't have these nice values, so the integer or fractional answers, and all we would do is use a calculator. But we're simply now considering writing the exponential equivalent or logarithmic equivalent to evaluate.